Now let's look at this interesting numerical which mixes the no claim discount with the concept of expected values kind of concept. Look at this. A motor insurance company operates a no claim discount scheme. Discount levels of 0%, 25% and 50% of the annual premium. So which means because of that discount the premium will be either 1000 if 0% discount is there, 750 if 25% discount is there, and 500 if 50% discount is there. Probability of having an accident during any year is 0.1, and we are saying the probability of more than one accident is ruled out. So the probability of no accident is 0.9. The policyholder moves up one level up in the discount scheme or stays at 50% in the event of a claim free year, moves one level down or stays at 0% level if the claim does not involve a criminal offense. So probably it is like, if I am talking about these 0%, then 25%, then 50%. Here also I am talking about 0%, 25% and 50%. Now from 0 he can move to 25 with a probability of 0.9. Whereas he will be at 0 only with a probability of 0.1, but he will not move to 50% at all. But if he is at 25, he can move to 50% with a probability of 0.9. He can come down to 0% with a probability of 0.1, but he will not be there at 25 at all. If the claim involves a criminal offense, then the policyholder automatically moves to 0. So from 50, if he does not create any kind of if he does not get into any kind of a claim, he will still be at 50. If he makes a simple claim, he will come to 25%. But if he makes a criminal offense, then he will come to 0. 1 in 10 accidents, so which means 10% of 10%. So 1% is the scope of he coming here, whereas 9% is the scope that he will come here. So this is the typical transition matrix. The policyholder makes a claim only if the cost of repairs is higher than the aggregate additional premiums payable in the next 2 claim free years. Right? So let's say if he is at 0%, in case he makes a claim, his premiums in the next 2 years, the worst case premiums in the next 2 years are 1000 in the next year, because he will be at 1000, and he will assume that he does not make a claim in the next year. The worst case is his claim amount is 1700, his premium amount is 1750. But assume that he does not make any claim. He is at 0, he does not make any claim. So in the next year he would have to pay 750, and the following year he would have to pay 500. So his only premium cost is 1250 only. So whether to report a claim or not, he will take a decision between these two. If he reports a claim, automatically his premium is becoming minimum of 1750. It will be more than that only, because if he reports the second claim, it would even more increase. So if he is reporting a claim itself, his premium in the next 2 periods is going to be 1750. But if he is not reporting the claim, his aggregate premium for the next 2 years is 1250 only, which means he will report a claim he will report a claim only when the real claim amount is greater than 500. If the claim amount is below 500, he will not report the claim at all for a person who is in 0% claim level. So calculate for each level of discount the cost of repair below which the policyholder will not claim. So when he is at 0% layer, when he is operating in the 0% layer, if he is claiming, then automatically his next 2 years premiums are going to be 1,750. Whereas if he is not claiming, his premiums are going to be 1,250. So the minimum claim amount that he would look out for is only 1,750 minus 1,250. So at least if the claim amount is 500, cost of repairs is greater than 500, then only he will make the claim. Let's say he is at a 25% level now. Alright, think of it like this. If he is at 25, let's say he is making a simple claim. If he is making a claim, automatically in the next year his premium is going to be 1,000. And even if I assume that the next year his the worst case, he is still not making any claim, still his premiums are going to be 1,750. But if he is not making any kind of claims in this year, his premium is going to be 500 in the next year and even 500 in the next year after that also, which means overall his he will make, a person who is at 25% level, he will make a claim only if the cost of repairs is greater than 750, because if he is reporting it, automatically his premium is increasing by 750 bucks. Suppose the person is at 50% layer, and here I will differentiate whether he is making a simple claim or a criminal offense. So if he is talking about a simple claim, okay, he will, if he is making a claim, he will fall one level down. So which means he will pay a premium of 750, and assume next year is a better year. So he is not making any more claims. So overall his claim premiums, that minimum premium that he has to pay is 1,250. Whereas if he is having 2 good years, claim free years, he will be paying premiums of 500 and 500 only. So which means he will report a claim only when the claim amount is at least 250. Whereas if he has done a criminal offense, then automatically his next year premium is going to be 1,000 and then another 750. Whereas if he is not making any kind of a claim, he will end up paying 1,000 only, which means again going with the same logic, he will report that claim only if he is around 750 or more, if the claim amount is 750 or more only. Any claim amounts which are below that are typically not reported, right? So that's the first part of the question for us. All right. Now, what is the second part telling? Calculate the probability of a claim for each level of discount. I have to find out the probability of a claim, assuming that it is done only if it is greater than a certain amount. Probability of a claim for each level of discount, given that an accident has occurred, given that the repair cost following an accident has an exponential distribution. So X, which is the repair cost, it is having an exponential distribution with the mean 400. So 1 by lambda is 400. So lambda is 1 by 400. So X is following an exponential distribution with a parameter of 1 by 400. Okay. Now I know that the distribution, the the cumulative distribution for this exponential distribution is 1 minus e power minus lambda x, which means the probability of x less than or equal to x is 1 minus e power minus lambda x, but the probability of x greater than x is 1 minus of 1 minus e to the power of minus lambda x, which goes as e to the power of minus lambda x. Now this is what I will try to bring in. For a 0% level person, I want to find out what is the probability that x is greater than 500. I can very well find out the probability that x is, so the probability of a claim is what I want to bring out. The probability that a claim is getting made here is e to the power of minus lambda x. E to the power of minus lambda is 1 by 400 times x is this much. So around 28.65%. Now if I go with the same logic for 25% guys, the probability of making a claim is this much, and even here it is 53 and 15. But again, going with the same, if I really have to look at it, this simple claim, the probability is 90%. There is a 10% that it is this claim. So if I really want to look at the probability here, the overall probability, then it is as good as, I'll call it as 0.9 times this number plus 0.1 times this number. So working out to somewhere around 0.49. So there is a 49% chance that at 50% level a claim would be made. There is a 15% chance that a claim would be made at 25% level, and there is a 28.65% chance that a claim would be reported at a 0% discount level. Alright. Now the next part is calculate the stationary distribution of the proportion of the policyholders at each discount level. Okay, here now the proportions will change. Let's try to go with that. So initially let's say 0, 25% and 50%, and here also I'll put let's say the original state being 0, 25 and 50. Now if a person from 0, he has to be in 0 itself, means he has to make an accident. But if he is making an accident, the probability of making an accident is 0.1. But he is not reporting that accident. So it's as good as probability of making an accident as well as reporting it. So which means it is as good as probability of accident multiplied by probability of reporting given the accident has already occurred. This is 0.1, and for this category, when in 0 category, it is 0.28. So this is the probability that he will be in state 0, which will be 0.1 times this number. So there is a 0.028 probability that he will be in state 0 itself, and he cannot move to state 50, which means the remaining, which is around 97.13% chance that he will move to state 25%. Now same way, if the person is in 25%, if he is making one claim, that is when he will move to 0. So again the same logic, the probability that he is making a claim or making an accident and probability of making a claim given the accident has occurred. So probability of an accident is 0.1, but probability of a claim given the accident has occurred is only 0.15 for this group. Rest all will not get reported at all. So which means this probability will become 0.1 times 0.15. and there is no way that a person can be in 25% level from a 25% level, and the remaining is the probability that he will move to a 50% level. So these are the numbers. Now similarly, look at a 50% person. If a person is already there at 50% level, now comes the 3. Okay, the probability of an accident, and if it is an accident, probability of a criminal offense given that it is an accident, and probability of reporting given that it is a criminal offense. This will take a person from 50% to a 0% level. So probability of an accident is 0.1. Probability of a criminal accident given an accident is again 0.1, and probability of reporting given that it is a criminal accident is 0.53. So which means here the probability will come out as 0.1 times 0.1 times 0.53. So this comes out to 0.00. Oh, for criminal is the next one. It comes out as 0.0015. Similarly, look at he going into the next from 50 to 25. Probability of accident is 0.1. Probability of non-criminal given an accident is 0.9. And probability of reporting given it is non-criminal is 0.53. So this number here comes out to 0.1 times 0.9 times 0.53, resulting in 0.048, and rest is he will be still at the 50% level itself. So this is the regular probability transition matrix for us. And now we are talking about a situation. Now we want to find out the stationary distribution. The stationary distribution for us comes out as pi p equal to pi itself. So I will take it as pi 1, pi 2, pi 3, or p1, p2, p3. Right? I'll call it as p1, p2, p3. This multiplied by the probability transition matrix 0.028, 0.971 and 0. Then I have 0.015, 0.984, some such kind of numbers. 0.001, 0.048, 0.95, some such kind of number. This should be equal to P1, P2, P3 itself. So P1 times this, P2 times this, P3 times this is equal to P1. Right? So here all we are talking of is 0.028 P1 plus 0.015 P2 plus 0.001 P3 is equal to P1. Similarly, 0.971 P1 plus 0.048 P3 is equal to P2. Then the third one is telling me 0.984 P2 plus 0.95 P3 is equal to P3. So from here I am getting 0.05 P3 is equal to 0.984 P2. So I can very well write P3 in the form of P2. Right? I can very well write or P2 in the form of P3. So P2 is nothing but 0.05 by 0.984 P3. So this I can very well manage it out. right, which is nothing but, so if I am talking about P2 here, it is nothing but 1 minus of this, which is 0.05 divided by 0.984, this one. So this is the value that is coming to, right, this is the value that is coming to P2 in terms of P3. So P2 is this much times P3. That's one expression which we have got, right? So here we now will go back to this equation, wherein 0.971 P1 plus 0.048 P3 is equal to P2. P2 is 0.050 P3. So here again I am getting my P1 also divided by 0.971. So my P1 comes out as 0.050 minus 0.048 divided by 0.971. So this much times P3. So this is for P1. So now I know three relations. P1 plus P2 plus P3 is equal to 1. So now P1 is there in terms of P3, P2 is there in terms of P3, P3 is there. So overall I will get my P3 now. The P3 comes out as 1 divided by 1 plus this number plus this number. So overall P3 tells me around 94.97%. Then P1 will become 0.002 times P3, which is around 0.002, and P2 will become 0.05 times P3, which is 0.04. Now this is what I can say, that the probability of staying in state 0 with this numerical, in the long term, the probability of staying in a 0% discount state is around 0.2%. The probability of staying in 25% discount state is 4.79%, and the probability of staying in the 50% discount state is around 94.98%. So this is the way we arrive at the stationary distribution solving. But apart from that, the major things that we have looked at in this numerical is the computation of the probability and the reporting part. So there is a Bayesian statistics angle that we have brought in terms of these calculations. All right.